Hi, in this STR8CHEM session, I'm going to walk through some problems in rate law. Let's have a look at the first question. Given the rate equation for a reaction rate equals to K, concentration of A to the power of 2. If concentration A is increased 3 times, then rate will increase by a factor of. So how do you solve this? Step number 1. First, you need to assume that the initial concentration will be 1.0 molar. You can use any number. You can use 2 molar, you can use 3, but I would prefer to use 1 because 1 is the most manageable number to be used. Okay? And then step 2, after you have assumed that, you need to look at what the question gives. So when concentration of A is increased 3 times, okay, so if concentration of A increased 3 times, like what we have written over here, and since we have assumed that initial concentration of A is 1 molar, and when you times by 3, the concentration now is going to be 3 molar. Okay, so this is the concentration after it is increased 3 times. So moving on to the next step, what you need to do. So rates, what we have there. So the rates is given here. So you're just gonna substitute. You're gonna take this 3. You're just gonna substitute into A. Then you get things like this, and 3 to the power of 2 you will have rates equals to 9K. When you look at the number 9 over here, that is how much the reaction has been increased. So the reaction is increased by a factor of 9, okay, because you have 9 over there, so it is increased by a factor of 9. So this will give you 1 mark for the final answer. You get 1 mark also right there, and this whole thing here, you will get 1 mark. Next one is the question in which the rate equation for 2A gas plus B gas to make C gas is rate equals to K times concentration of A to the power of 2, which is A will have a second order reaction and B has a first order reaction because it is to the power of 1. If the pressure is increased 2 times. Okay, so now the pressure, now we are talking about pressure increased 2 times. At constant temperature, the rate reaction increased by a factor of, so this one is quite similar to what we have over here. But in this question, it gives you concentration increased 3 times. So that's why you can do this. But this time you have pressure being increased 2 times. I have given you 3 notes over here. So these are very important notes, although they do not have any mark, but the notes will be very important to help you to understand what's going on. So let's have a look at note number 1. Note number 1. The question gives pressure is increased by 2 times right there. Okay, increased by 2 times. And the rates, if you look here, rates is in the expression of concentration, like what you have in here. Okay, both of them are in terms of concentration, but the question is changing the pressure. So how are we going to use this piece of information to solve this? So how do you do that? So you're going to use PV equals to nRT. You're going to use PV equals to nRT to relate P and concentration together. This is a very important piece of information. So you're going to use PV equals to nRT to relate P and concentration. So when you look at PV equals to nRT, you can try and rearrange that. When you rearrange that piece of information, you will get V. When you move to the other side, you have P equals to N over V RT. Remember, N over V over here is the same as concentration. Okay, so thus, it will be in terms of concentration. N over V, mole over volume, is concentration. When you look at what's going on right there, we can say that pressure is directly proportional to the concentration. Okay, pressure is directly proportional to the concentration. Therefore, pressure is directly proportional to the concentration. From where do we get that from? This piece of information over here is generated from the PV equals to nRT equation after you have rearranged it. And so if pressure is doubled, okay, so if pressure is increased by 2 times, because it is directly proportional, concentration will be increased by 2 times also. Okay, because of this relationship right over here. So now we're gonna continue with the steps. So we have looked at the 3 important notes. So step number 1, what you need to do is to assume initial concentration first. Again, we're always going to use 1 molar for everyone. So that is the initial concentration. Always going to use 1. You can assume by using different number. That's totally fine. Okay, but I like to use 1 because in this case, it is the easiest to work with. So step number 2, when concentration is double, because pressure is doubled, remember why we can do this? Because from the PV equals to nRT just now. The concentration now will be 2.0 molar for A and 2.0 molar for B, because you times by 2. So you have 1 times 2, you have 2. 1 times 2, you have 2. Now we have the concentration already, and we're gonna use what we have. Okay, right there. So this is the rates equation. So we'll take the information you have there. You're gonna substitute into the concentration of A and B to get this expression, and you get rates equals to 8K. So 2 is 2 right there, to the power of 2 times 2, you have 2. So 2 to the power of 2 times 2, you have 8. So look at the number 8. Therefore, the concentration will increase by a factor of 8. You have 1 mark. 1 mark. This whole thing over here will give you another 1 mark. Now, next question. Also, we have 3 important notes before we begin to proceed. If you look at the question, it has the rate law. At temperature T, you have reaction is R. How does the reaction rate change if the partial pressure of X2 is double? So that is the important bits. This is what the question wants. If you have partial pressure, you have the partial pressure of X is double and partial pressure of C is going to be half. Okay? So note number 1, so it's going to be the same as what we have done just now. The question gives partial pressure of X2 gas is doubled, okay? And the partial pressure of C2 gas is going to be times by half, okay? That is from what the question gives. But, again, rates, as you can see, the rates over here is in terms of concentration, okay? Like what you have in there. So we need to use, again, PV equals to nRT to relate concentration with partial pressure. So we're going to use PV equals to nRT again to find the relationship between pressure and concentration, like what we have done previously. Therefore, in note 2, you rearrange the ideal gas law. You will get P equals to concentration RT. Again, this is the indication that they will be directly proportional to one another. So because pressure is directly proportional to concentration, so if partial pressure of X is doubled, the concentration of X2 will also going to be doubled, okay? Because the relationship between pressure and concentration is directly proportional. And if the partial pressure is going to be half like this, the concentration of C2 gas is also going to be multiplied by 1/2. Why? Again, because the pressure is directly proportional to the concentration. Now, step 1. Again, I think you can guess it. So we need to assume that the initial concentration is 1 for both reactant. Okay? Like so. So you have, assuming initial concentration of X2, 1, C2, also 1. And then step 2, when you have X times 2, because you have double it, you will have the concentration of X is equal to 2.0 molar now. And the concentration of C2 gas, if the partial pressure of C2 gas is by half, then the concentration will also going to be half. Okay, and it's all because of this relationship. Pressure is directly proportional to concentration. So step 3. So you're going to take the rate law. Okay, you're going to take the rate law that is given to you right here, substitutes the value inside. Okay, so you're going to take this, you're going to substitute in there, and you're going to take that concentration, you're going to put in there to find the rate. So it will look like this. and therefore the rate is 0.5 K. But don't forget, you have a new statement over here, which is it needs to be in R. So you have to rewrite. So when rate of reaction is R, therefore the rate is equals to 0.5 R. Step 4, then we're just going to write the rate change by factor of 0.5. Okay? So we're just going to take that 0.5 there to write it there. So what about the mark allocation? You have 1 mark here. You have 1 mark for there. You have 1 mark for this whole thing. And you will have 1 mark for this whole thing right there. Next is this question. So the questions now is slightly more difficult because the question gives you information about the volume of the vessel is tripled. So how do you do that? Just now we are dealing with pressure and concentration. So that is quite easy when you do the comparison with PV equals to nRT. But this time, you need to consider a different formula to solve this. Question gives volume is tripled, so volume will be times by 3. Okay, so what is the relationship between volume and concentration? We need to find the concentration because the rate right there is in terms of, okay, so that is in terms of concentration. So since concentration is defined as mole over volume, okay, so we do know this formula is quite popular. So when you look at the equation over here, or the formula for molarity, concentration is inversely proportional to volume. Okay, concentration is inversely proportional to volume. So concentration is inversely proportional to the volume. Because of that, so when you have concentration is doubled, if you have the volume is doubled, concentration will be half because they are inversely proportional with one another. And if you have concentration over here is tripled, if the volume is tripled, the concentration will be times 1 over 3. Okay, so when the volume is tripled, the concentration will be times 1 over 3. And if you have the volume times 1 over 2 or half, the concentration will be the other way around. It will be multiplied by 2, just what you have done over here, and so on. Okay? So for this particular exercise, we are focusing on tripling the volume. So we are focusing on this. Okay, so now the concentration will be times 1 over 3. So step number 1. Step number 1, again, you need to assume that the initial concentration will be 1.04, both of them. Okay, both of them will have initial concentration 1.0. So that is the assumption that you need to make. And step 2, so when concentration is times by 1 over 3, concentration A2 will be 1 over 3 molar. and concentration of X2 will be the same as well. Okay, because they have the same initial concentration. And in step 3, what we're going to do is we're going to take the rates equation that we have right here given to you by the question, and we will be substituting the value that you have right there into the rates equation right there. Therefore, we will be getting something like this: K times 1 over 3 times 1 over 3. And you will get rates equals to 1 over 9 times K, because the question wants you to write in terms of X. If the rate of reaction is X at 300 K, so we have to write in terms of X, and it will look like this. When rate of reaction equals to X, therefore the rates will equals to 1 over 9 times X. For step 4, we're just going to write rate change by a factor of 1 over 9. So in terms of marking, you will get 1 mark right over here and 1 mark for the one in the green bits. This whole thing will give you another 1 mark, and that whole thing over here another 1 mark. Okay, so next question. So the last one for this video. Given 2NOBr gas to be decomposed into 2NO2 gas plus Br2 gas. If the question, or if the reaction found that it has a 4-fold increase, so we need to find out what is the rate law. Okay, we need to find out what is the rate law for this reaction. So this is an example of a HOTS question. I would consider that this is a HOTS question. So step 1. Again, you need to find out what is the question wants. The question wants rate law. So you have to write the general rate law first, which rates equals to K concentration of NOBr to the power of M. Okay, so because we don't know what is that power yet. And after that, by doing this, you should be able to get 1 mark. And then step 2. In step 2, question gives point number 1, rates increase by 4. Okay, so rate increase by 4. So this is a very important piece of information. Thus, you can write rates in this format. Okay, rates equals to 4K. So we have in that format, like what we have done just now. And then question gives second point in step 3. Question gives point number 2. The rate is 4K when the amount of NOBr is doubled. Okay, when the amount of NOBr is doubled. So that is for that statement over here. Thus, the rate K equals to NOBr can be written as this. Okay, so we can assume that that is initial is 1 molar. Then you're going to put it 2 there. So step 4, we're going to compare rate 4K and rate K times 2 to the power of M. So we're going to compare both of them. So when you compare that, you get 4K equals to K times 2 to the power of M. Okay, so I'm just going to replacing this rate over here with 4K because the rate is also equals to 4K. So when you cancel that out, you'll get something like this. And we're going to use ln. So you're going to put ln on both sides. So when you put ln on both sides, this to the power of M will go in front like there. And you get M equals to 2. So this, you get 1 mark for that. Okay. Therefore, it is going to be second order with respect to NOBR. So you get 1 mark for this. And the rate law right now is rate equals to K concentration of NOBR to the power of 2. So this, you have 1 mark.